Okay, this is the video on square roots. It's video number 15. Let us continue. Okay, let's look outline here, please. Square roots, we'll discuss what square roots are. Then we'll look at first principles of square roots. Then we'll go through square roots by observations, square roots of small perfect squares, square roots from vertically and crosswise multiply, square roots from vertically and crosswise divide. Then we'll introduce quadratic equation and see how they relate to square root problems. What's a square root? Square root is inverse of a square. In other words, if x is a square root of n, then x square is equal to n. Alternately, square root of n is solution of x squared equal n. If determine the value of x in equation x squared equal n, we are trying to find a square root of n. Let's continue here. Let's study first few squares. Okay, number, we're going to look at some numbers, their squares, and digit sum of the squares. Okay, let's continue here. 1, first number is 1, its square is 1, its digit sum of the square is 1. Okay, let's continue here. Number is 2, okay, its square is 4, digit sum of square is 4. Let's continue here. 3, number is 3, its square is 9, its square root digit sum of square is 9. Okay, let's continue here. 4, 16 square, and 7 is the digit sum. 1 plus 6 is 7. Let's continue here. Number 5, its square 25, and digit sum of 25 is 7. 2 plus 5 is 7. Let's continue here. Number is 6, square is 36, and digit sum of 36 is 9. 3 plus 6 is 9. Let's continue here. 7, number is 7, square is 49. 7 plus times 7 is 49, and digit sum is 4. 4 plus 9 is 13. 1 plus 3 is 4. Let's continue here. 8, number is 8, square is 64, digit sum of 64 is 1. 6 plus 4 is 10. 1 plus 0 is 1. Let's continue. Number is 9, square is 81, and digit sum of 81 is 9. Okay, let's continue here. Number is 10, square is 100, and digit sum of 100 is 1. Let's continue. Number is 11, square is 121, and the digit sum of 121 is 4. Let's continue here. Number is 12, square is 144, and digit sum is 9. Let's try to find a pattern. 1, 4, 9, 7, 7, 9, 4, then 1, 9. Okay, so this is sequence here. 1, 4, 9, 7, 7, 9, 4, 1, 9. Then it repeats 1, 4, 9, and next is a 7. Okay, and next is 7. Next. Okay, let's move into the next section here. And next section is first principles of square roots. These are axioms related to square roots. Let's continue here. Now, well-known first principles. I got these principles from Tirthaji's book. Perfect squares do not end in 2, 3, 7, or 8. If a number ends in 7 or 8 or 3 or 2, it's not a perfect square. Digit sum of perfect squares is not in 2, 3, 5, 6, and 8. Okay, digit sum of perfect square, you can have 9 possible values, and 5 of those are forbidden. Only 4 of the other. 1 is allowed, 4 is allowed, 7 is allowed, and 9 is allowed. Let's continue. 9 is allowed, 4 is allowed, 7 is allowed, 9 is allowed. 9 is allowed, 4 is allowed, 7 is allowed, and 9 is allowed. Let's continue. 9 is allowed, 4 is allowed, 7 is allowed, 9 is allowed. Let's continue. If perfect squares end in 1, its square root ends in either 1 or 9, and the two are tens complement of each other. 9 is equal to 10 minus 1, and 1 is equal to 10 minus 9, and 1 plus 9 is 10. Okay, these are self-complementary. They are tens complement of each other. Okay. A perfect square ends in 4, its square root ends in either 2 or 8. Again, the two are tens complement of each other. 2 plus 8 is 10. A perfect square ends in 5, its square root ends in 5, and 5 is its own tens complement, so it does not have another digit to worry about, only 5. Okay, its tens complement is also 5. Okay, let's continue here. A perfect square ends in 6, its square root ends in either 4 or 6. Again, 4 and 6 are tens complement of each other, so either 4. Okay, let's continue. A perfect square ends in 9, its square root ends in either 3 or 7. Again, 3 and 7 are tens complement of each other. Let's continue here. If a perfect square ends in 2 zeros, its square root ends in a 0. Okay. If a perfect square ends in a 0, it must end in even number of zeros. For each pair of digits or part thereof in a perfect square, there is one digit in square root. Continue here. If in a pure fraction like 0.23568 has n digits, its square has 2 times n digits. Exercises. Using the observations studied so far, determine if the following can be perfect squares. Okay, let's continue. First example, 41503, 50178, 2354, 37093, 53384, and some more. Okay, let's continue with the next section here. Okay, next section is about square roots by observations. Let's continue here. Okay. Continue with the section here. For some special cases like square of numbers near base number, square of numbers ending in 5, square of numbers in 50 through 59, we can determine square root by observations. Okay, because we know the square and we can use that observations and to determine square root. Okay, let's continue here. Example, square of 98 is 9604, so square of root of 9604 must be 98. Okay. Let's continue here. Square of 101 is 10201, so square root of 10201 is 101. Let's continue here. So then square root of 102. Let's continue. Some example here. We know that square of 111 is 12321. So square root of 12321 is 111. So it's 1, 2, 3, and then fall back 2 and 1. Let's continue here. We know square of 33 is equal to 1089. That means square root of 1089 must be 33. So square root of 110889 is 333. Square root of 11108889 is 333. Okay, let's continue here. Square root of 1, 2, 3, 4, 5, 6, 7, 8, 9, and then decreasing 8, 7, 6, 5, 4, 3, 2, 1 is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Number of nines is given by the largest digit in the square here. Okay, 1, 1, 1, 1, 1, 1, 1, 1, 1. Let's continue here. Square root of 9998001 is 9999. Okay, let's continue here. Square, we know square of 89 is 78, and which is double the deficiency here, and the square of 11 is 121, and we need two digits, so one get carried to the left, so it's 79, 7921. That means square root of 7921 is 89. Let's continue here. Let's look at some of the squares of numbers ending in 5. Okay, when we know square of 35 is 1225, that means square root of 1225 must be 35. What would we do? We split 1225 into 2, and we notice that 25 is on the right and 12 is on the left. If we can find two factors of the type n times n plus 1, we know that n is the digit on the left. So 12 is equal to 3 times 4, so square root is 35. 3 is a smaller number and 4 is one more than before. Let's continue here. Of 75, we know square is 5625, so if we need to do 5625 square root, it is 75. We notice that 25 on the right and 56 on the left is equal to 7 times 8, that gives me 7 on the left. Let's continue here. Of square of 95 is 9025, and square root of 9025 is 95. We know square of 125 is 15625. 156 is 12 times 13, so square root of 15625 is 125. 5, this 25 gives the 5 in the end, and 156 is 12 times 13, and that gives me 12. Let's continue here. Square of 24.5 is 24 times 25, and on the right is dot 25, that means 25. So 620 dot 600 dot 25. Okay, so square root of 600.25 is 24.5. Let's continue here. Square root of 4.5 is 20 decimal 25. So square root of 20 decimal 25 is 4.5. Square of 65 is 4225, and square root of 4225 is 65. So what we see 25 here is split in 2. 42 on left is 6 times 7, that gives me 6. Let's continue here. Square of 115 is 11 times 12, and 25 on the right, 132 25. That gives me square root of 132 25 as 115. What we do is, let's continue. The split in 2, 25 gives me 5, and 132 is 11 times 12, and that gives me 11 here. Now we'll consider some more examples here. When we are dealing with squares of numbers in this range 50 through 59. Okay, let's continue here. We know that square of 50 is 5 times 5 plus 0. 0 is this one here on the left, and 2 zeros, which is 0 times 0. Square the digit on the right, and we need two digits is 2500. That means square root of 2500 is 50. So we know square of 57 is 25 plus 7, 7 here, and 5 times 5 is 25. 25 plus 7, and on the right is 7 square 49 is 3249. So square root of 3249 must be 57. So what we do here is, this is a 7 squared, and this one is 25 plus 7. So if this is square root of the digit number, two digits on the right is 7, and if this is 25 plus 7, then I got myself a square root of 57. Okay, square root of 52 is 25 plus 2 on the left, and 0 4. I need two digits. 2 times 2 is 4, but I needed two digits here. So 2704. So 2704, pair of digits on the right, square root is 2, and if this is 25 plus 2, which it is, then 5 is the left digit. Okay, continue here. Square of 53 is 25 plus 3, 09, 2809. So that means square root of 2809 must be 53. Okay, square of 54 is 2916, and square root of 2916 is 54. Square of 155 is 3025, and square root of 3025 is 55. See the 55 square root of 55. You can also find this is ends in 5, so we can use the previous formula, which is on left is a 5 times 6, which is 30. On the right it is 25. Let's continue here. 56, 25 plus 6 on left, on 36 on right, 31, 36. That means square root of 31, 36 is 56. Okay, then square of 58 is 3364, because 25 plus 8 is 33. So square root of 3664, square root of 3364 is 58. Okay. Square of 58 is 3364. The square root of 3364 is 58. Let's continue. Square of 59 is 3481. And that means square of root of 3481 must be 50. Let's do some exercises. Okay. Just redo the problem discussed as examples here and make your own practice problems. I did not include any exercises here because I included most of the exercises as examples. So redo them and take your time. That's all for this section. Okay, let's continue with next section here. In this section, we'll discuss square roots of small perfect squares. Okay, square roots of small perfect squares. Let's see what that is. We use the method for square root of perfect squares of length 3, 4, or 5. Let's continue here. Here the steps are split into two parts with the right part consisting of rightmost two digits. And find left digit of the answer from the table of squares. Okay. Let's see. Find two options of the right digit from the rightmost digit. Let's continue here and resolve the ambiguity of the units place. In units place, you have two options and usually two options. Okay. And we resolve the ambiguity of the units place. Okay. Let's continue. Example, we're going to do a square root of 2916. Here's my table of squares. This is my cheat sheet here. Square of 1 is 1, that of 2 is 4, of 3 is 9, of 4 is a 16, of 5 is 25, 6 36, of 7 it's 49, of 8 it's 64, of 9 it's 81, of 10 it's 100, of 11 it's 121, of 12 it's 144, of 13 it's 169. Okay, let's split the number in two just like we discussed before, 29 and 16. 16 is the rightmost digit, two digits, and 29 is whatsoever is left over on the left. Okay, obtain the left digit from the table on the left. 29 is between 25 and 36, and we'll use the lower number 5. So left digit is 5. From 29, leftmost digit of the answer is 5. Okay, and right digit is either 4 or 16. We got 6 in here and a 6 in here. 6 in the rightmost digit means either 4 on the right or 6 on the right. Okay. The two options. Now we know for sure left digit is 5, given this is a perfect square. Okay. So left digit is 5, right is either 4 or 6, and we have to resolve the ambiguity. Let's see what we do. For that, we use the following method. Either we use digit sum method or compare against the square of left digit and 5 on the right, or compare against square of the n values. Okay, let's continue here. This is my cheat sheet again. Two possible values are either 54 or 56. Okay, digit sum method. Okay, let's say 56 is what we're trying to. My first choice is digit sum of 56 is 11. Digit sum of 56 squared is digit sum of 11 times digit sum of 11, which is 4. Okay. And digit sum of 2916 is 9. So there is a contradiction. They do not match. Okay. This digit sum is not confirmed. Okay? We cannot confirm that, so that is my wrong option. Let's consider the other one. 54, digit sum of 54 is 9, and digit sum of 54 times 54 is also 9. So that's a confirmation here. So 54 is the answer. So digit sum of 2916 also 9. So confirmation, and 54 is the square root of 2916. So we have confirmation of the digit sums. Okay. Let's, so here's my cheat sheet again. Next example is 7569. We split in two, 69, two digits on the right, everything else on the left. On the left we have from 75, it's 8. It's between 64 and 81. Left digit is 8. Left digit is, right digit is 9, which means either is 3 or it's either 3 or 7. So left digit is, has two options here, 3 and 7. Okay, we'll use a comparison with square of 85. So we get, okay, and 85 is average of 83 plus and 87. So 85 times 85 is 8 times 9, and the right digit we don't matter. Okay, we know it's 25, but we don't use them. So 72, and this number is 75. 75 is larger than 72. That means we'll use the larger option for the right digit. 7225, which is 75 is greater than 72, and we choose the maximum of 3 and 7. So that means square root of 7569 is 87. Let us consider another example. 14161. Square root of 14161. Let's continue here. Here's my cheat sheet. Here two parts are 141, 61. Rightmost two digits on the right and everything else on the left. Left part is from table on left is 11. Okay, 141 is between 121 and 144, and 11 is the are the digits for the square root on the left. Yes. Right is a 1 here. 1 appears against square of 1 and also against the square of 9. So options for right digit are either 1, 9, 1 or 9. Okay. And 1 and 9 are 10's complement of each other. 1 plus 9 is 10. Let's continue here. We know that if it's 1 was the answer, digit of choice, then we would have 111 times 111, which is 12321. And which is not the same as 14161. However, 14161, the one we are looking for, square root of 14161 is larger than 12321, and so square root of 14161 must be 119, not 111. Let's continue here. We in fact wish to use compare with the bounding square. Desired square root is in 110 squared and 120 squared. In square root is within 110 and 120, and not using either of them. Okay. So square of lower number is 12100. Okay, and this number 14161 is larger than that for sure. And square higher number is 14400. Okay, and clearly 14161 is closer to the larger number, higher square number. Okay, so that means we choose larger of 1 and 9, which is 9. So that means square root of 14161 is 119. Let's look at some exercises. Okay, find square root of following perfect squares. Okay, 5929, okay, 11025, 14641, 900, 1089, 841, 12321, and some more. Continue with next section here. In this section, we will do square roots from vertically and crosswise multiply. Okay, let's continue here. Let's look at square root problem. Square root problem is you try to find n is equal to square root of x. Try to find x, square root of x, we say let it be n. Okay. If we were to square both sides, which is n squared is one side and x is the other. Okay, we have n squared is equal to x. Okay, x comes from n times n. Okay, and so n squared is n times n. And how we compute n times n? We remember the vertically and crosswise multiplication. We will use vertical and crosswise multiplication to compute n times n. And how about squares using duplexes? We also have computed squares before using duplexes, which is also vertically and crosswise multiply. That in this section, we will just consider square root of perfect squares only and reverse at using vertically and crosswise multiply. Let us continue here. Example, we will take the square root of 22781529. Number of pairs in the number are 4. So number of digits in square root is 4. Okay, and okay, so let's see how we are going to proceed. We know that there are 4 digits in this square root. From the first principles, we know number of digits in square root is 4. We know leftmost digit of the answer, which comes from square tables, and we use 22 to compute the leftmost digit, and that's 4, because 22 is between 4 squared, which is 16, and 25, which is 5 squared. So we'll use a lower number of the 4 and 5. That's 4 is my left digit here. Rightmost digit is from 9 here, is in the set 3 and 7. 3 plus 7 is 10. So these two are tens complement of each other. So either it's 3 last digit, it's a 7. And we can say that only when there is a perfect square. So this number is given to be a perfect square, and 4 is leftmost digit, 7 rightmost digit is either 3 or 7, and number of digits in the square root are 4. Okay. Let the 4 digits be number A, B, C, D be the square root of this number. That means A, B, C, D times A, B, C, D is 22781529. Let's continue here. First we know A is 4. Question is, where does leftmost 22 come from? So 22 here we have A, B, C, D times A, B, C, D. In this multiplication, where does that leftmost digit number 22 come from? This is the leftmost pair. Okay. So here is my multiplications here. A, B, C, D times A, B, C, D. When we try to compute leftmost pair of these numbers here, we use A times A plus any carry from the right. It comes from vertically multiplication of leftmost digit A times A plus any carry from the right. Okay, let's continue here. Okay. So A times A plus carry is equal to 22. This 22 here must come from A times A plus any carry we got from the right. That means A is equal to 4 and carry is equal to 6. We already know the leftmost digit is 4 and carry must be 6. Carry from right must be 6. Okay? When we multiply, the added number is a carry. Now we are reversing the multiplication, and which is like a division. We may call that a remainder. So instead of carry, we would be calling this a remainder. Okay? Let's continue here. So remainder from this step is a 6. So we have 4 as leftmost digit. A is equal to 4 and remainder is 6. Okay. Is the problem so far? ABCD times ABCD is 22781529. A is 4 and remainder is 6. We have leftmost digit 4. Okay, now with 6 as a remainder from previous step, next dividend is 67. So next dividend is 67 here. Okay. Now what we will divide by? Where does 67 come from in the multiplication? Okay, so 67 is the next digit of the answer, is the next number on the right. Okay, let's continue here. So we have this multiplication here. We got 22 from 4 by times 4 plus any carry, and now we are next digit to the right, and that comes from these two digits here. We got two columns of the numbers to work on. Okay, let's see what that is. What's that is? 4b plus 4b, which is 8 times b, and plus any remainder from here is 67. That means b is equal to 8, and remainder is equal to 3. Largest b I can get is 8, and still have a remainder of 3. Let's continue here. So we have a next dividend from with 3 here, and 8 next digit is 38. Okay? So that's my 38. Now let's see where does 38 come from. So the 38 come from, and now we have a 3 digits of to multiply. I know 4 here, 8 here, and a c. We are determining a equal 4, and so far we have b is equal to 8, and c we are trying to find out right now. Okay, let's continue here. So it comes from 4c plus 4c, 8c plus 8 times 8, 64. That means that just 8c plus 64 plus remainder is 38. Then 8c plus 64 plus r is 38. R 8 when we 8c plus r is minus 26. That means c is equal to minus 4 and r is equal to 6. To keep the remainder positive, because we will be carrying carries from the right would be positive, so we would have a c is equal to minus 4. So that may we have overshot. Oops, we have overshot. How do you correct? Any ideas? Do you remember altered remainders we used in divisions? Backtrack to determining a higher remainder in previous step. So altered remainders was we're going to backtrack and we will determine a higher remainder in a previous step. That means we come back to 67 here. A is equal to 4 and remainder is 6. Okay, let's continue here. That means we use a value 8 before, now we'll use 7 here. 8 times b plus r is 67. Okay, let's continue here. Then b is equal to 7 and r is equal to 11. Let's continue. We're using altered remainder. See? That means next dividend is 118. Okay, let's continue here. Okay. Okay, so where the 118 come from? It comes from these three digits multiplication: 4, 7, and a c. A is equal to 4, B equal to 7, C we are trying to determine. We tried first time around, we got negative values and we backtracked. So we would give another attempt. So now we have a 2 times 4 times C. 4C here and a 4C here. That's 8C plus 49. 8C plus 49 plus R is 118. Okay. Okay, let's see what happens. 8c plus r is equal to 118 minus 49, which is 69. Okay, that means c is equal to 8 and r is equal to 5. Okay, that would result in an okay. Let's look to the right and see where we are going to get into. That will get me, if I use 8 for c, so c becomes 8. Okay, and the next step, so we would be multiplying these number together. Okay, and okay, if we use a c is equal to 8, r equal to 5, then means we'll end up being using it. Remainder will be 5 here, so the next number dividend will be 51. That means 8 from here, 4 times 8 and 8 times 4, that's 8 times 8 here. plus 7 times 7, 49, plus r is equal to 51. Again, r would be negative, so we will backtrack right away and use a lower value for c and a higher remainder. Let's continue here. That means c is equal to 7 and r is equal to 30. So in this equation here, if I use c is equal to 7, that would get me r is equal to, instead of 5, we'll get 13 here. Okay? That's altered remainders. Let's continue here. So we have a is equal to 4, b equal to 7, and c equal to 7, and remainder is 30. Let's continue. Next dividend is 131, right here. Okay, and where does now we don't have a d yet. Okay, 131 comes from where? Comes from here, which is a 4d plus 4d, which is 8d right here. 7 times 7 times and plus 7 times 7, that's this number here. So 8d plus 98 plus r is 131. Let's continue here. 8d plus r equals 131 minus 98, which is equal to 33. Okay? That means d is equal to 4 and r is equal to 1. So remainder 1 is a little too short, smaller number, and further we know that it's a perfect square and d is either 3 or 7. Okay, so we would be overshooting using 4. Okay, let's continue here. However, that would mean that at next step, so if I use d is equal to 4, so I will have a 4 times 4 and 4 times 4, which is add them together becomes 32, and 7 times 7 plus 7 times 7 is 98. I mean 2 times 4 times 4 plus 2 times 7 times 7 plus r would be 15. This 1 here and 5 next digit. That's again r would be negative if I use that. So we go back, do altered remainder again. We'll use d is equal to 3, which is consistent with the first principles here. So r would be negative if I use d equal to 4. Okay? That means use d is equal to 3 and r equal to 9. So if a d is 3 here, 8d plus r is 33, then okay, and then remainder would be 9. If I say 8 times d plus r is 33, if I have d is equal to 3, then 24 plus r is 33 and r would be 9. And d equal to 3 is consistent with the first principles. Let's continue. So what do we have right now? We have a is equal to 4, b is equal to 7, c is equal to 7, d is equal to 3, remainder is 9. Okay, and the next dividend is 95. Okay? 95. Let's continue here. And now we have this 4773 times 4773. We use all the digits. We start dropping columns on the left. Okay, so that means that 7 times 3 plus 7 times 3, that's 2 times 7. And then multiply 7 times 7 plus r is 95. So that means this part is 42, this is 49, and plus r is 95. That means 42 plus 49 plus r equals 95. That means r is 4. Okay. So the next step we have a next dividend with 4 here with 42. Let's continue here. Okay. So now we'll drop another column here and 7 times 3 and 7 times 3 is 42. Okay. So then 2 times 7 times 3, next step plus r is 42. That means r becomes 0. Okay. For next step we have a digit 9 here and r. Okay, so we have all digits here and we have r equal to 0. Okay. That's 0, 9. Okay. Next dividend is 9 and 9 comes from 3 times 3, so remainder is 0 again. Okay. That means our square root is 4773. Let's continue here. That means square root of 22, 78, 15, 29 is 4773. Let's look at observations so far we made. Square root of 22781529 is leftmost digit is 4, which come from square root of 22 from the table. There's no division required here. 100 place of is digit 7, which come from 67. Remainder 6 here, divided by 8, and that come divided by 8. So we had to divide by 8 on the second step. In tens place is from 118. Okay, that's this 8 here and 11 remainder. And we did 118 minus square of 7 here, 49. We divided by 8, and that means we did subtract duplex of 7, and we divided by 8. So no division here, first step. Second step, there is division only, and third step we have subtract and division. Okay. Units place is from 131 minus 98 divided by 8. Okay. So we have 13 remainder from the previous step here, 131 minus 98 divided by 8. Okay. We were subtracting a duplex of 77. There were 2 sevens before the third digit, and we got it, and we were dividing by 8. So we divided by 8 here, divided by 8 here, divided by 8 here, and 8 is twice of the first digit. Leftmost digit comes from square root and does not contribute to subtracted duplexes. So leftmost 4 is, we don't use 4 in any of the subtractions here. For all other digits, we divide by 8, which is equal to twice the leftmost digit. These digits come from division. So these first digit 4 came from square root table of squares, and the rest of them need a division. Divide by 8 here, divide by 8 here, and divide by 8 here. Before dividing by 8, we subtracted duplex of digits computed so far and excluding leftmost digit. So leftmost digit 4 is not using any duplexes, and so before we divide by 8, we subtract duplex of digits computed so far and excluding the leftmost digit. Exercises. Okay, so we can do some exercise here. Find square root of the following perfect squares. So note that any number in here you can assume they are perfect squares. Okay, first number is 29192409. Next is 13271449. Next 49491225. Next 174724, and some more. Okay, let's go to the next section here. Okay, in this section we'll do square roots from vertically and crosswise divide. Let's continue here. Square roots from vertically and crosswise divide. Let's continue here. Background. What's vertically and crosswise divide? Do you remember doing that before in a previous video? Answer. That is straight division. Straight division is where we split the divisor into two parts. One is divide by part, the other is adjust for parts, and adjust for part goes on the flag. They make the flag digits. Let's continue here. So what do we do in straight division? Okay. In straight division, we have a dividend and a divisor. By dividing, we determine quotient and the remainder. So we have, when we were in straight division, we were given a problem in which we had a dividend specified and a divisor specified. Okay. Let's continue here. Sometimes we decimalize the remainder. Okay, instead of remainder, quotient remainder, sometimes we also do a decimalized remainder. Okay. Let's continue here. What are the basics of vertically and crosswise division? Let's see if you still recall what is involved in vertically and crosswise division. Okay, answer, it's divide and conquer. Okay, So we divide the division into two parts, divide by part and adjust for part. From there, adjust for part becomes the flag digits. Okay? So we make the adjust for parts as the flag digits. So if we had example of dividing 886675 by 3102, so what do we do? First we do is 3102 is equal to 3000 plus 102. Okay, divide by part is 3000, which is equal to 3 times 1000. Adjust for part is 102. That one here, 102. So first two step division we do, first we divide by 1000 and then by 3. And flag digits are 102. So we first divide by 1000 and then by 3. So problem setup is like that. Here is my dividend. Here is my divisor in two parts. Okay. Here is a 102 is flag digits and 3 is a divisor, which is the then by 3. And here is that divide by 1000 here. First divide by 1000 and then by 3 again and adjust for by 102. So this is the setup and this is your background for vertically and crosswise divide. Let us see how we are going to use same thing in computing a square root. Okay, let's do now square root now. Okay, in division we will need a dividend and a divisor. Dividend we actually have, divisor we will have to find out. Okay? Dividend is given number. Given number we are trying to take a square root of is the dividend. Okay, and what's divisor? Let's find out what divisor is. Okay, is there any divisor given? The only thing we are given is a square root of. Need to find out square root of a given dividend or given number. So we need to find that out. Square divisor we don't know. From previous section we know that we were dividing by 2 times the leftmost digit. Okay, we know that we were dividing by 2 times the leftmost digit. That will be our divide by part. That will be our divide by part. By the way, 2 times x come from first differential of x squared. Okay? Let's continue here. What's the adjust for part? So we know we are going to use a straight division, which is vertical and crosswise divide. Okay? And we just found out that we are going to divide by this 2 times leftmost digit. Okay? And adjust for part. Let's see what that is. And we also need a flag digits. Let's continue here. In this case, it will grow dynamically. Okay? In this case, it's not a fixed number, but it will grow. Okay? Where the decimal point go to? See, we were dividing in two steps. One in the previous example by first by 1000 and then by 3. And division by 1000 give us a hint of where does the decimal point go to. And where would decimal point go in here? So we don't have a two-step division here, but we still need to figure out where decimal points go. Let's continue here and use first principles to determine number of whole digits in square root. Okay? After we know the whole digits in square root, we can determine where the decimal point would go. We can apply this lessons of the previous section here into determining square root of 35319249. That's 8 digits of the number. Okay? Square root of 35319249. So first we make a pairs in square. We need to figure out how many digits in the square root are. So we get 4 pairs. 35, 31, 92 and 49. 4 pairs. So leftmost digit comes from the table of squares and from 35. So from that table we have 5 is the leftmost digit of square root and remainder from that is 35. We only used 25 of the 35 and so remainder is 10. Okay, let's continue here. And divisor would be 2 times this 5. 2 times 5 equal 10. That is our divisor. Okay, we would be dividing by 10. Let's continue here. Now let's set up the problem for division here. So problem is 35. From that we got a 5 here. Then 3, 1, 9, 2, 4, 9 are the, we have not used these dividend digits yet. From this 5, I got 10, twice as much as the divisor. And from this remainder 10, that goes with the next dividend digit to make a next dividend, gross dividend is 103. Okay, let's continue here. Now we need to figure out where the decimal point go to. Okay, number of whole digits in square root are 4. So this two digits give me 1. This thing would give me another digit. This one would give me another digit, and this one would give me another digit. That means decimal point would go right in the here. We need 4 whole digits in square root, 4 pairs, 4 digits, whole digits in square root. So that's my, so we just divided by 1000. That's basically, and this decides my decimal point goes right here. So make the position of decimal point. Now just mark the position of the decimal point here. Let's continue. Okay. Problem so far is first quotient digit is 5, divisor is 10, and remainder is 10, and we have 103 for gross dividend. Okay, let's continue here. Next gross dividend is 103. No digits on the flag, and net dividend is also 103. Let's continue here. So 103 divided by 10 is, we will use 9, remainder 3, 13, which is alternate remainder. If we did use 10 remainder 3, that would advance my first digit to 6, and which violates my first principle. So 9 remainder 13 is what we are going to use. That means 9 goes on the flag, 9 goes in quotient digit, and 13 goes as a remainder which gets added, appended to the next dividend digit. Okay. You see that we also added same digit to the flag also. We got 9 here and 9 here. Let's continue here. You recall from previous section we were subtracting duplexes. This setup would do the same thing. Okay. Adjustment to the flag would be 9 times 9 is 81, which is the same thing as a duplex of 9. Okay. Now we have next cross dividend is 131. We would be adjusting that. Okay. Let's continue. Cross dividend for next is 131. Here. Okay. So next cross dividend 131 from previous slide, and adjustment is 81. Let's see where that come from. It come from 9 times 9. This is my vertical and crosswise multiplication setup. Okay, 131 minus 81 is 50. So we would divide 50 by 10, and we will use 4 remainder 10. Okay. We just alter remainder. 5 remainder 0 would be make it a next position is too small and won't be able to subtract whatsoever the adjustments are. Okay, so we'll use 4 remainder. So the 4 here and remainder 10, and 4 goes on the flag also. Let's continue here. Next cross dividend is 109, right here. And now we'll adjustments. Adjustment will be 94 times 94, which is a duplex of 94, and this is a cross vertical and crosswise multiplied. 9 times 4 is 36, plus another 36, 72. So 109, that 109 here, minus 72 from here equals to 37. Let's continue here. We will divide by 10 again, is same process. 37 divided by 10 is 3 remainder 7. Okay, 3 remainder 7. We've got a 3 here and remainder. 3 goes in here, 3 goes in here, and 7 goes in here. This quotient digit 3, the same quotient digit 3, and remainder 7. Let's continue here. Gross dividend is 72 now. Okay, that is 72 right here. And we are in the section after the decimal point here. So now next adjustment would be 943 and 943. 943 times 943 is a duplex of 943, and we will just figure out what the adjustments are. So net dividend, this give me 70. 9 times 3, 27. another 27 here. 27 plus 27 is 54, plus 16 here, 4 times 4, 70. So 72 minus 70 is 2. Okay. Next, okay. We'll do a 0. 2 divided by 10 is 0, remainder 10, 2. Okay, let's continue. So that's 0, remainder 2. Okay, 24 here. So next gross dividend is 24, and let's go to 0 here. Continue here. The next gross dividend is 24. Now adjustments. So we get 9430 here, 9430 here. That's duplex of 9430. 9 times 0 is 0, 0 times 9 is 9, 4 times 3, and 12, and another 12, 24. Okay. So now net dividend is 0. So we get net dividend 0, we got 0, remainder 0. So 0 goes in here, remainder 0 goes in here, the quotient is 0 goes in here. Let's continue here. Gross dividend is 9. Okay, now let's adjustments here. So we got adjustments is now 94300 and 94300. So this is 0, this product is 0, this product is 0, this product is 0, and 3 times 3 is 9. Okay, that's my adjustment is 9. Net dividend 0. Yeah, so we got 0 in the end. So that means now we stop. Remainder is 0 and no more digits to continue with. Okay. So we will stop because the remainder is 0 and no more digits to continue with. So square root of 35319249 is 5943, and it's a perfect square. Sections in decimal is, we got all zeros in decimal sections, so it's a 5943.000, which is 5943. Square root of this number 35319249 is 5943. Continue observations. What the observations from a previous section is, we use straight division to find square roots. So we use the straight division, which is we call it vertically and crosswise division. Okay. First quotient digit came from the table of squares. Okay. So we use the first principle for the first digit of the square root. The division was double of the first quotient digit. So we started with the divisor came in from first double of first square root quotient digit, first digit of square root. Flags came from subsequent quotient digits. As we continue to compute further quotient digits which are in division, which we are trying to square root, so next subsequent square root digits of the answer, then they also went on flag. We continued division past the decimal point section. Okay, we continued this division even after the decimal point was reached. Okay, all quotient is past decimal points were 0. In this example here, everything was 0 after the decimal point. So it was a perfect square. We were our example number was perfect square. Okay. Note, VM books do not use the flag digits. Instead, the books use duplex of all the quotient digits except the very first quotient digit. Okay. The two treatments are equivalent. Okay. You use the one you prefer, but this one looks to me clearer that it is still just straight division, which is also called vertically and crosswise division. Now we're going to have an example where it's not a perfect square and its number is 665496. Only you got 6 digits of the number here. We will do the up to decimal, 2 decimal places. Okay. Let's continue here. So we'll do a square root of 665496. Let's continue here. We make pairs here like 665496. 3 pairs. So they mean 3 digits before the decimal point, and that's a 3 whole digits of the answer. Find leftmost quotient digit from table of squares. That digit is 8, and from 66, square root of 66 is a whole number is 8, and then remainder is 2. Let's continue here. So divisor is 2 times 8 is equal to 16. And number of whole digits is 3 from first principle, 6 pairs and 3 digits. Now 3 pairs and 3 digits. This is 6 number. There are 3 pairs here and 3 digits in the square root. The problem setup is 66, 5496, 8 as my first quotient digit, and 16 is my first divisor, and 2 as a remainder which get prepended to the next dividend digit. Okay, let's continue here. And number of digits, whole digits is 3, so that means that I got one digit here, and I would get one here and one here, so that the decimal point would go here. Okay, let's continue. Okay, so problem so far was 66, 5496. Decimal point go here. 8 was first digit of the quotient, or first digit of square root, and 16 is our divisor, and 25 is our gross dividend in the next step. Let's continue here. Gross dividend is 25, no flag digit so far. Net dividend is also 25. And divide 16 by 25, divide by 16, 25 divided by 16 is 1, remainder 9. Okay, so 1 goes in here, the quotient digit, and 1 goes in the flag digit. 9 remainder comes here. Okay, net gross dividend 94, adjustment is 1, 1 times 1, okay, which is 1 times 1 here. Is a duplex of 1 is 1, and 1 times 1 is 1. Okay, no dividend digit, net dividend is 94 here. 94 minus 1 minus 1 times 1, 93. We'll divide 6 by 16. That 93 divided by 16 is 5, remainder 13. So 5 is the quotient digit and 13 is the remainder. So the 5 quotient digit here, 5 goes in the flag, and 13 comes in here. Let's continue here. Gross dividend digit is 139, right here. Adjustment is 10. Let's see where 10 comes from. 10 comes from, it's a duplex of 15. Duplex of 15, it is 1 5 times 5 1, which is 10. 1 times 5 5 plus 5 times 1, which is also 5, and 5 plus 5 is 10. Adjustment is 10. Net dividend is 139 minus 10 is equal to 129. Okay, so far we had 139 minus 10 as net dividend here. 10 comes from here. 129 is 10 is also duplex of that, and also 15 times 15. Net dividend is 129 divided by 16. We will use 7 remainder 17, not 8 remainder 1. That will get me a negative situations later. So that's altered remainder. We use 7 remainder 17. 7 is the quotient, remainder is 17. 7 would go here, 7 would go here, and 17 would come in here. Let's continue here. So we are at 7, 7, and 17. Okay, so adjustment for next step would be like that: 157, 157. Okay. Gross dividend is 176. Adjustment is 39. 7 times 1 is 7. 7 times 1 is 7. 7 plus 1, 7 is 14. And next is 5 times 5, 25. 14 plus 25 is 39. That's adjustment. Net dividend is 176 minus 39, which is 127. Let's continue here. Now we're going to divide again. We would say 127 divided by 16 is, I just use negative number now. 8 remainder 1. Okay, negative 1. 8 remainder negative 1. Okay, okay, so 8 goes in here, 8 goes in here, and I'm going to forget about doing any more because we are doing it up to 2 decimal places. Okay. We're going to come to the end because we're trying to get 2 decimal places. This is second decimal place, and I'm perfectly happy with using a negative remainder here. Let's continue. So we got a square root of this number 665496 up to 2 decimal places. It's 815 dot decimal 78. Now you can do some exercise here, and square root of fallen to up to 2 decimal places, and some of the numbers might be perfect squares and most of them are not. Okay, let's continue here. Square root of 91681125, square root of 118228800, square root of 2765869, and some more. Let's continue with the next section here. And And what I want to discuss here is intro to quadratic equation. I don't want to equations here, solve them, but I'll show you how the relationship to this vertically and crosswise method, division method of square root. Okay, let's continue how we could use the same method we just discussed into solving these problems here. So far in this video we have studied square root of a number. Okay, and that problem is we try to solve for x in a x squared equal n. Solve for x in a x squared equal n. So in these problems we have determined leftmost digit. This is what we did. The divisor was twice that number, and which is also first differential of x squared equal to x. That is x squared here. First differential is 2 times x. We found first digit of x, and that is what we used for twice of that as a divisor. Now, if you change the problem with a times x squared, okay, so x squared is n divided by a, divide both sides by a, that's what it is, okay. From that we can determine leftmost digit of the quotient and remainder. From this n divided by a, we can determine what the leftmost digit of the quotient and also what's the first remainder is, okay. Oh, yeah, we just divided by a here, we can also say transpose and apply. Transpose a to the right, and this was multiplied by term become divided by term on the right. Okay, let's continue here. Divisor will be 2 times the a leftmost quotient digit. Okay. Oh yeah, if we do ax squared here and do a first differential, that time 2 times a. So it that would give me the leftmost quotient digit would be times leftmost quotient digit. Instead of multiplying by 2 of the digit, we would be multiplying by 2a. Okay. Differential of ax squared is 2 times a times x. So we got first quotient digit and we multiply that by 2a. That would be our divisor. Okay. We can also determine number of whole digits will be number of pairs in whole digits of n divided by a. So if you need to do how many whole digits there are, we can compute n divided by a and see how many pairs of uh, are in whole digits are in n divided by a. Here. So now we're going to make this adjustment here. Next variation is to ax squared, we would add bx equals n. Now we have quadratic, this is a quadratic equation here. Here we will determine x by trial and error. So we'll determine x and left side using most of the right side. Okay. We'll try to find x such that left side uses most of the right side and give the whole digits of parts of x and also a remainder. Okay. We are trying to get a positive remainder when we are more comfortable with the positive remainders. Okay, let's continue here. Divisor would be 2 times ax plus b. First differential of ax squared plus bx is 2ax plus b. So we determine x and divisor would be 2ax plus b. From there we can continue straight division to find digits after digits, digits after decimal point. So we can use this this method we just discussed, straight division method, to find the other digits after the decimal. Okay? And we intend to keep these equations in a later video. We'll take up these equations in a later video, and here's your introduction so that if you need to look into and try and get comfortable with, maybe you go ahead and work them out. References. Okay, our references are Vedic Math Teacher Manual Volume 1, which is a elementary level by Ken Williams. The book is available from vedicmaths.org. PDF form is free and the print form you can purchase. Vedic Maths by Bharti Kishan Tirtha ji, that's the main primary reference for anything on Vedic Math. Okay. Discover Vedic Math by Ken Williams, that's most complete, authoritative and consistent notation it has. It uses organization is by the sutras and not by topics. Continue here. Vedic Math for Schools in 3 volumes by James T. Glover. Glover used these books in his school and these are very readable. Vedic Math for All Ages by Vanna Singhal is not as complete as other two books are, but this is a very readable and it's a nice way to get it introduced to Vedic Math. That is it.